At organic chemistry, and we're specifically going to look at our experiments based around benzoic acid. So we're going to look at the production, recrystallization and melting point of benzoic acid. So first we'll look at the preparation of benzoic acid. And benzoic acid is prepared by oxidizing phenylmethanol using potassium permanganate in the presence of sodium carbonate, and it produces benzoic acid. So we also have this balanced equation here, and there is 7 main stages to completing this experiment. So let's take a look at those 7 and see what characteristic or key information that they have. So the first step is the mixing of reagents, and in our conical flask at this stage we have phenylmethanol, we have potassium permanganate, and we have sodium carbonate. So step 2 is heating of our reagents. So our reagents are placed in a water bath and left to heat. And in our conical flask at this point we will still have our phenylmethanol, our potassium permanganate and our sodium carbonate. But once the heating starts to take place, we will see a reaction start to happen, and we will get a colour change from purple to brown. Once heating is complete, we form sodium benzoate, manganese dioxide, potassium hydroxide and water. And the solution is cooled under a tap of flowing cold water. So step 4 is acidification of the cooled solution, and it is acidified with hydrochloric acid. On to step 5, and we have the addition of sodium sulfate, and at this point the benzoic acid crystals will have formed. There will be benzoic acid solution and some dissolved impurities. So once we add the sodium sulfite, we cool the solution again, this time by placing it in an ice bath, and at that point we have benzoic acid crystals and dissolved impurities. The benzoic acid solution doesn't disappear. Crystals come out of the solution due to their low solubility at cold temperatures. And finally, we have filtering of the crystals, where benzoic acid crystals are left in our filter paper, and the filtrate containing other soluble products goes into our Buchner flask. So let's look now at each stage in greater detail. So in stage 1, we said that we use potassium permanganate and phenylmethanol and sodium carbonate in order to kickstart our reaction. So our KMnO4, or our potassium permanganate, will be saturated, and that have alkaline condition. And this is because the reaction proceeds best under alkaline conditions. Moving on to stage 2, as I said, during heating we will get a colour change, and the colour change is purple, indicating that the manganese is in the +7 oxidation state, and that will change to brown, indicating that the manganese has been converted to the +4 oxidation state. So the +4 and the brown colour indicates the formation of manganese dioxide, which is not soluble in the water. Stage 3 then is the cooling of the solution, and during this cooling process we form an intermediate called sodium benzoate. And also during stage 3, a glass rod is dipped into the solution and checked on blue litmus to check the acidity of the contents of our conical flask. Now, in stage 4 is acidification of our solution, and the reason the acid is added, there's 3 of them. The acid is added to convert the sodium benzoate to benzoic acid. It's to neutralize any of the excess sodium carbonate or potassium hydroxide that is present. from our necessity in step 1 to have alkaline conditions. And finally, it's to enable the Mn+4 or the manganese dioxide to reduce down to Mn+2 in stage 5. So in stage 5 we do have the addition of sodium sulfite, and the sodium sulfite is added as a reducing agent to help ensure that the Mn+4 or the manganese dioxide, which is brown in colour, converts to Mn+2. And it's at this stage here we begin to see some white crystals forming. At stage 6 then, we have cooling again, and here our conical flask is placed in ice, and it's placed in ice to allow quick cooling to maximise the yield of benzoic acid crystals, and that is because benzoic acid crystals have low solubility at cold temperatures, and that is very important to remember for this experiment and the ones that are to follow. Stage 7 is the last one, and it's filtration, and basically your solution in your conical flask is filtered and your crystals are obtained in your filter paper. But it's important to know that the kind of filtration that happens is suction filtration, and the reason suction filtration is used is it helps to dry the crystals. And that's it for preparation of benzoic acid. So next we're going to look at the recrystallization of that benzoic acid sample that has just been prepared. And to begin this, it's important to know what recrystallization is. So recrystallization is a process of repeated crystallization in order to purify a solid or to obtain more satisfactory crystals from a solid that is already pure. So I would always say that recrystallization increases the purity of a sample that you are working with. So with our recrystallization of benzoic acid, there is 5 main steps. The first one is dissolving the sample obtained in a minimum amount of hot water. The second one is hot filtration. Third is crystallization. Fourth is cold filtration. And the fifth is drying. So let's look at these steps now in greater detail. So to begin, let's look at the contents and changes that occur during each of these stages. So our sample will have been prepared in our preparation of benzoic acid experiment, and the first thing that we will do is we will dissolve in a minimum amount of hot water. So at this point in our conical flask we have a saturated benzoic acid solution containing soluble impurities and insoluble impurities. We ensure that we are dissolving in a minimum amount of hot water because benzoic acid crystals are very soluble at high temperatures, and we want to use the minimum amount of hot water in order to keep our saturated solution. Step 2 is hot filtration, and the first thing that's important to know here is that the hot filtration is gravity filtration. So in our filter paper, what we collect is we collect the insoluble impurities, and in our conical flask then what flows down through the filter paper is benzoic acid and our soluble impurities. We want hot filtration here because we do not want our benzoic acid crystals to crystallize in our filter paper. Step 3 then is crystallization, and in crystallization what we do is we place our conical flask into an ice bath, so we are cooling it down, and as a result of cooling it down we have a benzoic acid solution where benzoic acid crystals will start to form, and we have soluble impurities. So because we've cooled it down now, we're going to do cold filtration, and we do cold filtration by suction filtration, and the reason for this is we want all of our soluble impurities to be sucked through into our Buchner flask, and what we'll be left behind with is our benzoic acid crystals in the filter paper. So once we have the benzoic acid crystals, the last stage is drying, and here the benzoic acid crystals are dried using the air or in a desiccator. So let's just look at these stages now in a small little bit more detail to reinforce what I've said here. So as I've said already, stage 1, we ensure to use a minimum amount of hot water because we want a saturated solution. And we use hot water because we want to ensure that our crystals remain in solution. Stage 2. Stage 2 removes the insoluble impurities that are present, and all equipment must be hot to prevent the crystallization of the benzoic acid. We want to keep our benzoic acid in solution. Fluted filter paper is used in this gravity filtration stage because it will give a greater surface area to allow for quicker filtration. Stage 3 then, our solution is cooled to allow the benzoic acid crystals to form, and the reason it's cooled is because benzoic acid crystals have a low solubility in cold water, and impurities remain in solution to be filtered in the next stage. So although the benzoic acid crystals crystallize out, our impurities still remain in solution. So stage 4 is where the soluble impurities are removed and the crystals are filtered and washed with ice cold water. The reason they're washed with the ice cold water is to ensure that all of the soluble impurities have gone down through the filter paper. And last stage then is stage 5, which is drying, and the crystals can be air dried or dried in a desiccator. And that's it for the recrystallization experiment. The last experiment that you would do with your benzoic acid then will be to measure your melting point. And to start this, it's important to know what melting point is. So our definition is that melting point is a range, and it is the difference between the temperature at which the first crystal starts to melt and the temperature at which the last crystal fully melts. Impure benzoic acid will melt at a lower temperature and over a wider range. So the more impurities that are present, the lower the temperature will be and the wider the range. And we know that pure benzoic acid will have a melting point of somewhere between 121 and 122 degrees. That is the range. So for melting point, there's no real major steps that you need to know, only that the benzoic acid crystals are put into a capillary tube, which is placed in a melting point block, and the temperature is recorded from the time the first crystal melts until the last crystal melts. So let's just have a quick look at an exam question that's come up on benzoic acid. So this is the exam question from 2015. And it says 1 molecule of phenylmethanol can be oxidized to 1 molecule of benzoic acid using potassium permanganate under basic conditions. And these are the reactions shown. So let's try some of these questions. So part A asks us to describe the appearance of the phenylmethanol at room temperature, and phenylmethanol at room temperature is a colourless liquid. Part B says state the colour change when phenylmethanol was heated gently with the potassium permanganate solution to which sodium carbonate had been added. So we know that our first colour change is purple to brown, with the oxidation state of the purple being the Mn+7 going to the Mn+4 manganese dioxide of our brown. Next part of part B then says identify A and B in the reaction scheme that were added to allow separation of the benzoic acid from other substances after oxidation was complete. So A is representing the acidification stage. So with acidification we know that we acidify with hydrochloric acid, and then we know that this part here for B, that is our reduction from Mn+4 to Mn+2. So that occurred by the use of sodium sulfite. Then it says what changes are observed in the reaction vessel on addition of these two chemicals. So on addition of these two chemicals, we get that the brown colour disappears and we have the formation of white crystals. Then the last part there says state the changes in oxidation number of the manganese during the experiment. So the manganese goes from the +7 to the +4 and then goes to the +2, and that is indicated by the purple colour changing to the brown colour and then changing to the brown colour disappearing. Part C then says, after isolation by filtration, the benzoic acid crystals were purified by recrystallization. State one way of maximizing the yield of recrystallization process. So, one way of maximizing the yield would be to use a minimum amount of hot water. And this occurs during step 1. Another example could be stage 2, which is hot filtration, and the reason it's hot filtration is to ensure that the crystals don't recrystallize. The next part of the question says the melting point range of benzoic acid before recrystallization was 112 to 118. How would recrystallization have affected the melting point range? So it would have narrowed the melting point range, because we know that recrystallization is a way of purifying a substance. So if a substance is pure, it has a narrower melting point range. Part D of this question then was a calculation based on theoretical and percentage yield, and it says a student oxidized 2.7 centimeters cubed of phenol methanol with a density of 1.04 grams per centimeter cubed and obtained 1.83 grams of benzoic acid after recrystallization. Assuming the phenol methanol was the limiting reagent, calculate the percentage yield of the benzoic acid. So here it would be important before we start to say that our actual yield is 1.83 grams, and in the first few steps of this experiment we're going to calculate our theoretical yield. So we need to convert our 2.7 centimeters cubed into grams, and we know that if we do volume multiplied by density, that gives us the mass. So that's what we're going to do here. We do the 2.7, we multiply that by 1.04 grams, and that gives me 2.808 grams. Now, that 2.808 grams, I need to convert to moles. So to go from grams to moles, you must divide by your molecular mass. So I need to divide by the molecular mass of the phenol methanol, and that works out to be 108. So if I do 2.808 grams and I divide that by the molecular mass, which is 108, I get 0.026 moles. Now, I want to see how many grams of benzoic acid are in 0.026 moles. So I must multiply by the molecular mass of our benzoic acid. And from calculation, we can see that that's 122. So that gives me 3.172 grams, and that is my theoretical yield. So now I know to calculate my percentage yield, I have to do actual over theoretical, and you can multiply that by 100 to get it as a percent. So I know that my actual yield is 1.83 because that was given in the question. My theoretical yield is 3.172, and I multiply that by 100, and that gives me that my percentage yield is approximately 58%. That's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.